solving rational equations. There are two methods that you can use. The first one is what we're going to use on these first few examples, and that is the method of using proportions. So you condense it into a proportion or a single rational expression on the left side, and on the right side you've got a fraction equal to a fraction. What can you do with a fraction equal to a fraction? Cross multiply. Okay, you can cross multiply, and that's what we're going to do. Or when we get to some more complicated examples, I'm going to show you a method using the LCD, and that's kind of what I showed you with complex fractions. But we'll get to that eventually. But we're going to use the proportions to start with. So for these first four examples here, we have a single fraction equal to a single fraction. So we can simply cross multiply, and then let's see what happens when we cross multiply. 7 times x is 7x. Is equal to, now this is where a lot of people tend to mess up. They don't put parentheses around expressions that have more than one thing. So you got to put 4 times parentheses x plus 6, okay? It's not just 4x minus 6, it is 4x minus 24 is what we're supposed to have on that right side. Now it's just a simple linear equation. Okay, it's very, very easy to solve. We subtract 4x from both sides, so we've got 3x is equal to negative 24. So we divide both sides by 3, so x is equal to negative 8. Now, I'm not going to box my answer yet, because sometimes with these equations, our solutions don't work out. Okay, we get them as an answer, but then they don't work when we plug them back in, and we call it an extraneous solution. So you should always, always, always check your answers. I mean, anytime you're solving an equation, you should check them. But especially in this case, you need to check it and make sure that you put parentheses around the negative x minus 6 in the bottom, or it's not going to look like it works out. But both sides here give us negative 0.5, so negative 8 is the solution. Okay, let's look at number 2. We got a little bit bigger expressions here. We've got 3 times 2a plus 1 is equal to 7 times a minus 8. So we've got 6a plus 3 on the left side. We've got 7a minus 56 on the right side. Again, it's still a linear equation. We've just got variables and constants on both sides. So I always like to move it to the side where the variable's bigger, so I don't have to deal with negatives as much. Therefore, I will move the 6a and then add the 56. So we get 59 is equal to a, which seems like a bigger answer than we're used to getting. Usually our answers are a little bit smaller than that, so I would definitely check this one. Again, don't forget, you got to put parentheses if you have any pluses or minuses involved in your denominators or numerators. And we get the same value for both sides. So 59, although it looks odd, is the answer. Okay, let's look at number 3. Same scenario, fraction equal to a fraction, so we can cross multiply, but what happens when we cross multiply? R times R, and just for the sake of being clear, I'm going to just write it like that this first time. Some of you can probably, most of you can skip this step once you get used to these. R times R gives us R squared. And then when we distribute that 4, we get 4r minus 4. What kind of equation is this? It's not linear, it's quadratic. Quadratic equations must be equal to 0 in order to solve. So we need to move the 4r and the 4 to the right side by subtracting the 4r and adding the 4. Did I just say right side? Left side. Subtracting the 4r and adding the 4. Then it'd be great if we could factor. Can we factor this expression? Yes, we can. Does anybody remember what we call this one? It has a special name. Yay! Perfect square trinomial. It is. Because look at what happens when we factor it. Negative 2 times negative 2 gives us positive 4, and negative 2 plus negative 2 gives us negative 4. So we get the exact same linear factor. it's a perfect square trinomial. Okay, so we've got r minus 2 is equal to 0, r minus 2 is equal to 0. Technically, we don't have to write it twice because it's the exact same solution. But remember those scenarios where we ended up with a repeated root or a repeated solution? We also use the term multiplicity. This is the solution is r equals 2 with multiplicity of 2. What would the graph of that look like? What would be different about that parabola? Anybody remember when we have a repeated root like that? That quadratic r squared minus 4r plus 4. The answer is 2, so it touches the x-axis at 2. It doesn't actually cross, it just touches. So that has nothing to do with the solving the rational equation. It was just a good little opportunity to review that idea there. We could check it, but I'm just going to go, plug it in. 2 over 2 minus 1, that's 2. 4 over 2 is 2. So we're good. Okay, let's look at number 4. Cross multiply. M plus 3 times m minus 2 is equal to 3 times 8, which is 24. I was shocked at the number of people that did not FOIL things correctly on the quiz. And I just did that in the wrong order. I'm talking about FOILing correctly, and I did it inside first. Some of you just multiplied the first 2 terms and multiplied the last 2 terms. That's not good. Okay, so combining like terms, the negative 2m plus 3m gives us a positive m. If we move the 24 over, we have to subtract it. Hopefully I'm not doing too much in one step for you. So that's minus 30 is equal to 0. So now we can factor. Positive 6, negative 5. So m equals positive 5 and negative 6 are our solutions. I would definitely check it since I've got 2. So 5 plus 3 over 3, 8 over 5 minus 2. Okay, 5 checks out. Let's check negative 6. Negative 6 plus 3 over 3 is negative 1. 8 over negative 6 minus 2 is negative 1. So both of those answers right there check out. Okay, so here's what I want you to do. I want you to attempt numbers 5 and 6 on your worksheet.